Hi there, CU Weather Nerd here. It's about 1Z. This forecast is for Tuesday, April 9th, 2013. This is a first potential severe weather outbreak on the Central Plains. The setup is relatively non-traditional, relatively linear in nature, and currently is covered by an SPC slight risk extending from southern Iowa and Nebraska all the way down into Texas with a 30% hatched. Looking here at water vapor imagery, we can see the clear trough with our dry air here, along with some potential vorticity coming over Baja California where the air is driest, and some clear air waves showing the strength of that. Looking here at the 250 millibar analysis, we can see a very energetic jet streak entering to the base of the trough, ready to eject, as well as a relatively deep trough there, and some diffluent flow downstream. Looking quickly at the GFS, this is the 30-hour forecast valid at 0Z on Wednesday the 10th, so 24 hours from now. We can see the trough here has ejected the first part of this jet streak, a large amount of diffluent flow here, and so we should see some response to that. And stepping down lower into the atmosphere, this time using the NAM, about 500 millibar vorticity here, and we can see the very energetic shortwave at the base of that trough, and the first bit of this energy really ejected out into the plains. And so this will provide some interesting surface impacts. This forecast is valid at 21 UTC tomorrow, so let's back that up a little bit here to 12. And so just looking here at our 12Z, this is just not going right. There we are. There we are. The 12Z forecast for tomorrow, we can see we have our cold front stretching here from Omaha down into Kansas. A small surface circulation here down towards that city, and a temperature gradient stretching into the panhandle regions as well. And as we move this forward in time, this is 15, 18, 21 to 0Z, we can see that cold front really becoming quite progressive, and by 3Z certainly overspreading all of the impact area. Moisture field wise, again, this is valid at 12 UTC. We can see we have a dry line stretching here from the panhandle regions, and up into Nebraska here we can see it's co-located with our cold front. As that cold front becomes more progressive tomorrow, it's going to overtake the dry line, and where that happens, of course, we will see a much more linear event. And already here at 3Z, we can see that that is the kind of the whole story of the day. By 21 UTC, anywhere in Kansas is certainly already been overtaken. One thing I do want to bring to your attention is while the surface boundary here, this is a NAM run for 0Z, surface boundary runs right through here. The cold front is relatively not vertical. You can see here's the 850 millibar temperatures, and remember our surface boundary was through here. This is a big question for tomorrow. If we can get storms to form prefrontal to the surface, we will see a much better severe risk than if we can see them forming more in response to the 850 millibar front. If they form in response to the 850 millibar front, we will see more elevated base thunderstorms and a lesser likelihood of any severe weather, of note at least, in Kansas. And I should note this forecast discussion is biased towards the northern targets because I'm based in Kansas City, and since this will be a largely linear event, I am not very inclined to drive into, say, central Oklahoma when I can drive to, say, Emporia and get a similar impact. I use GEMPAC here quickly to look at how the storm is going to behave. This is the NAM, and this is valid at 15, 18, etc. So we can see our boundary in here. And to orient yourself, here would be the Kansas City metropolitan area through here. Omaha will be here, Manhattan, Topeka, etc. 3Z here. So let our GIF here run again. Go out west a bit. So starting this off here at 12, now 15, we can see strong surface convergence along our boundary. The surface circulation located down here in southern Kansas. And by 21, that circulation is still kind of anchored here. And at 0, seeing that come north a bit, and by 3, seeing it certainly come north towards, say, Topeka. The GFS here, looking at the surface temperature and dew point gradient, is a little wider. That could just be a factor of the GFS resolution. And really the key point here is they paint a very similar picture of a cold front overtaking the dry line, of a small surface circulation attended somewhere through central Kansas. The biggest difference I can note is the boundary east-west here across northern Missouri happens a bit closer to the Missouri-Iowa border, whereas the NAM brings that 64-degree rich moisture up towards the Omaha area. So the NAM currently having a slightly more northerly track. I did want to pull the 3Z NAM to your attention. And just to look at this area here, we do see a relatively strong amount of surface convergence. And so this may aid in creating a focusing mechanism for some severe weather closer to the Kansas City metropolitan area, and may serve to also keep this from being just a straight line and seeing some bit of a echo wave pattern to it. Looking at helicities, this is 12, 15, 18, 21, and 0Z. And then at night, we can see a pretty healthy area here at 0Z of 175 to 300 meters per second helicities all the way along the interested area. So we do have at least a decent amount of helicity kind of at this overview look. And of course the area behind the front we're not terribly interested in. The EHI, of course, is a nice way of looking at this in combination with instability, and we can see 18, 21, 0, and 3. We can see that strong intensification of EHI in response to sunset and the beginning of the strengthening of the low-level jet, along with some higher EHI values along a northern target around 21 UTC. Looking at how the NAM thinks this will evolve convectively, here's a precipitation composite reflectivity product. This would be valid at 12, 15, 18, 21. 0Z, we can see some of that initiation pretty far to the west, suggesting it will be elevated base, way that looking at where the 850 versus the surface boundaries were, along with some initiation in northern Missouri. And by 3Z, really having strong initiation all the way along our surface boundary here. Probably the ongoing outbreak by this point. The GFS not having a composite reflectivity forecast, I'm just going to use 3-hour accumulated precipitations, and you can see here 15, 18, 21, and then 0, 21, 0, and then 03. You can see a pretty similar picture with initiation up and down the combined cold front dry line through Oklahoma and all the way to northern central Kansas and into say the Falls City, Nebraska area. And that goes away. Just looking at two soundings here. This is Emporia at 0Z. You can see we have a lapse rate that is close to saturated very deeply in the boundary there, but closer to 700, we still do have an inversion present. So there is still even a cap here, although the forcing of the front's of course going to be enough to overcome something like that. Any kind of convective activity will actually be relatively marginal. And so a lot of our lower of energy is going to have to come from these surface features and less from thermal energy. And that's one reason why I'm not so sold on prefrontal storms. However, overnight, like let's say 10 o'clock local, 3 o'clock UTC, I do want to look at the photographs for those. They do show me something somewhat interesting. This forecast sounding is for just south of Kansas City. Already start to see our nocturnal inversion forming, which could be a death knell for any surface-based thunderstorms. Of course, convective outflow, all kinds of features could keep these things anchored a little longer. But if we look at the hotograph, we can see the sickle shape through here. This shape has been correlated in the past to stronger and violent tornadoes. Also can be correlated pretty strongly to severe weather in general. So while it's not our nice, large, looping hotograph that kind of is the textbook definition, this sickle-shaped hotograph is nonetheless something to keep our eye on, and it's certainly repeated throughout our boundary. Looking down here towards Wichita, a really quite, interesting looking hotograph, one certainly of note in And so maybe as nightfall happens, our storms may take advantage of some of that better mid-level winds and may see some tornadic activity, even if it's embedded. I want to use the nested NAM to just kind of look at what might happen. This is a 1 hour precipitation forecast. This product hasn't updated for a while. Unlike the 18Z data we've been using, this product will go through its new updated 0Z. So this is a little bit more out of date, but it's the newest stuff we have for it. And considering the HRR will be down tomorrow, products like this will be very important. So you can see 230123 here. We can see our front through here, and some prefrontal initiation, both around Kansas City, but also down a little bit more here towards like Coffeyville, Kansas. Updrafts in these storms, of course, so we'll kind of see where the thunderstorms are actively thunderstorms. And it would be nice to have a timestamp, wouldn't it? We can see those updrafts really don't start until the 1Z time frame or so. So it looks like we have about 2 hours before sunset of kind of chaseable time with sunlight, and then after that, of course, you're chasing by lightning. I do want to look at updraft helicities here. So we did have some very nice helicities in those updrafts, and we can see they do combine. Near Kansas City, we have 2 thunderstorms, and as well a little bit along the front. So some of these prefrontal, or at least kind of maybe surface frontal thunderstorms 01, 02, 3Z near Kansas City are interesting to me, and they may be my primary target. Especially living in Kansas City, this is terribly convenient. The nested NAM's prog of composite reflectivity, we can see how those storms would be ideal given our setup. I mean, obviously not as ideal as had there been a surface circulation that kept the dry line and the cold front separate, but something to watch, and certainly will impact my forecasting tomorrow using the nested NAM and along with visible satellite and other things. Refining my chase into this area here makes the most sense to me. So chasing strategies. Emporia, Kansas is about 2 hours away. And this area is relatively kind of your typical Midwestern area. Gridded 1 mile roads, relatively good network. If you go just a little farther, of course, you run into the Flint Hills, and the network is not nearly the same. So there are kind of 3 options here. The first is to play the enhanced helicity along the cold front early in the day, 21 or so, up here towards Manhattan, and hope that something can take advantage of that. The second is to allow for a little bit more insulation and advection of high cape, which is what my current strategy is. And play near Emporia here. Basically, the idea would be to stay in front of the surface boundary and also ahead of any storms, because of course, if these storms are going to be larger linear, the features we're interested in are going to be on the eastern flank of the storm, shelf clouds, things like that. The worst thing to happen here would be to let that line pass, get stuck behind it, and have to come back and forth through it. We'd like to let these storms keep coming to us and retreating and kind of getting a nice picture of them several times. Do that and keep our eyes on the possible initiation through here. At nightfall, of course, using data to play safely, and kind of retreating back home towards Kansas City and hopefully playing the 0 to 3Z storms that should be initiating in this area here, which I think have the best potential of producing a tornado, at least within my local area. This event, of course, is much wider spread than just Kansas City and the Topeka area, and it does extend all the way down into Texas, which is where the SPC has denoted higher severe probabilities and hatching. That being said, I don't expect this to be a major event in terms of kind of like the best setup of the year or anything by that. So I'll remain relatively local and play the storms as they come to me, save some gas, and get my feet wet. At least it's something, and it's better than sitting at home. I look forward to any discussion here on Reddit, and thank you for paying attention. This is CU Weather Nerd.